At about 8:40 in the morning, local time, on Wednesday, the 26th of August, seismic stations in Germany and in the United States registered a tremor coming out of the Himalaya. The machines did what machines do. They logged it, they sized it, they passed it along. The first reads put it near magnitude 4.4, a moderate earthquake in a mountain range that produces them constantly. Nothing that would lead a bulletin anywhere in the world. Those instruments were not broken. They were simply reading the wrong crime. Because whatever moved on the Nepal and Tibet border that morning did not move the way an earthquake moves. And by the time anyone worked out what the seismographs had actually recorded, a churning wall of water, ice, and pulverized rock had already run the length of a Himalayan valley, crossed an international border, and hit villages that had no idea anything was coming. No rain fell that morning, no siren sounded, no fault ruptured. Something else happened, and what follows is the reconstruction of it, minute by minute, from the moment a mountain left a fingerprint that belonged to somebody else. If you want the mechanism rather than just the headline count, subscribing puts Earth signal in front of you as this one keeps moving, because it is still moving by the hour. Start with the instruments, because the instruments are where the confusion began, and the confusion is the whole story. A seismometer does not know what caused the ground to shake. It knows only that the ground shook, how hard, for how long, and in what pattern. From that pattern, analysts work backwards. An earthquake has a signature. Rock snaps along a fault, energy releases in a sharp burst, high frequencies arrive first, and the whole thing is over in seconds. That signature is so familiar that automatic systems flag it and publish it within minutes, all day, every day, worldwide. What arrived on the traces that Wednesday morning looked, at a glance, close enough. So the automatic answer went out. An earthquake near the Nepal and China border. Then the geophysicists looked closer, and the shape was wrong. The United States Geological Survey revised the assessment. The signal, they concluded, had not been generated by an earthquake at all. It had been generated by the landslide itself, by an enormous mass of ice and rock leaving a mountainside and slamming into the ground below, hard enough to ring the planet like a struck bell. When the energy was properly measured, it came out equivalent to a magnitude 5.2 event. Let me put that in terms you can feel. A magnitude 5.2 releases roughly the energy of a moderate munitions detonation. It is enough to crack plaster and knock objects off shelves in a town nearby. Nothing on this earth deliberately built by human hands falls off a mountain with that much energy behind it. This was a piece of the Himalaya letting go. There is a specific reason scientists can tell the difference, and it is one of the more elegant pieces of modern Earth science. Falling mountains produce long-period seismic waves, slow, deep, rolling energy, rather than the sharp crack of a fault. Gyirong Ekstrom, a geophysicist at Columbia University who studies exactly this kind of event, published work more than a decade ago showing that those long waves can be run backwards to reconstruct the slide itself. How long it lasted, which direction the mass traveled, how much potential energy it lost on the way down, roughly how much material moved. In other words, the mountain did not just make a noise. It left a description of itself in that noise. It just took people a while to read it, and while they were reading, the water was already in the villages. Here is what the reading, combined with satellite imagery from orbit, now says happened. High above the Lhende Khola, a river valley roughly 12 miles northeast of the Rasuwa and Gyirong border crossing, sits a glacier. It has no widely recognized formal name in the international record. Some early reports simply called it the Lhende Glacier, because of the watershed it sits in, though even that should not be treated as settled naming. Alton Byers, a mountain geographer at the University of Colorado Boulder who has spent years organizing research expeditions in these ranges, was blunt about it. That glacier had not been heavily studied. Nobody was watching it closely. At an elevation of about 17,000 feet, a substantial section near the lower end of that glacier broke loose. 17,000 feet is higher than any peak in the continental United States. It is thin, cold air where helicopters struggle and where almost nobody goes. And the piece that separated did not slide gently. It fell. Satellite analysis puts the drop at roughly 1,200 meters, which is close to 3,900 feet, onto the valley floor beneath. Think about a mass of ice and rock falling the height of 3 Empire State Buildings stacked on top of one another, and then think about what that mass is doing to everything it lands on. It did not stop there. On the way down and along the valley, it behaved less like a falling object and more like a liquid. Glaciologists call this an ice and rock avalanche. The ice fragments, the fragments lubricate the flow scours the slope, and the slope surrenders more material into it. Boulders, sediment. Loose moraine left behind by centuries of glacial retreat. The thing that arrived at the bottom of the valley was substantially larger than the thing that left the top. And then it reached the Lhende River and did something that turned a mountain accident into a mass casualty disaster. It dammed it. This is the hinge of the entire event, and it is the part most coverage moved past too quickly. The avalanche debris piled into the river channel and blocked it. Water kept arriving from upstream, the way water always does, and with nowhere to go, it began to pool behind the obstruction. A lake formed where no lake had been that morning. Nobody downstream knew it existed. Nobody upstream could have drained it. A natural dam built out of loose ice, rock, and mud is not a dam in any engineering sense. It has no spillway, no core, no reinforcement, and no design. It is a pile, and a pile holds until the water finds a weakness, and then it does not fail gradually. It unzips. When it went, everything the mountain had loaded into that valley went with it at once. Jeffrey Cargill, a senior scientist at the Planetary Science Institute, ran the numbers on how fast the resulting flow traveled. His analysis puts the average speed down the first 22 kilometers at about 193 kilometers per hour. That is roughly 120 miles per hour, sustained as an average over the opening stretch. Sit with what that means in practice. The surge covered nearly 14 miles in 6 minutes and 50 seconds. That is faster than the traffic on most highways you have ever driven. It is faster than you could outrun on the best day of your life, faster than a warning phone call could be placed and answered, faster than a person standing on a riverbank could climb to safety once they saw it. In many mountain valleys, the moment you can see the flow is the moment you are already inside its arrival window. This is the cruel arithmetic of high mountain hazards, and it is why the word flood is almost misleading here. A flood implies water rising. This rose the way a door slams. What came down the valley was not clear water. It was a slurry of water, mud, shattered ice, and rock, dense enough to move vehicles and heavy enough to strip valley walls. The first inhabited places in its path were on the Tibetan side and at the border itself. Mud and debris hit Gyirong Port in the Shigatse region, a busy trans-Himalayan crossing where trucks, traders, workers, and travelers gather. Security footage from the Chinese side captured the moment the wall of mud arrived. Many people had no time to move. On the Nepali side, the surge poured out of the Lhende Khola into the Bote Koshi, then into the Trishuli River, and headed south. Timur and Sayabrubesi, settlements in the Rasuwa district immediately below the border, were among the first hit. Then it kept going. Nuwakot, Dhading, places like Betrawadi, Trishuli Bazaar, and Devagat, well downstream, where people had every reason to believe they were nowhere near any mountain. The International Center for Integrated Mountain Development recorded what happened to the water level at Galchi in the Dhading district. The Trishuli rose by as much as 9 meters in 30 minutes. 9 meters is nearly 30 feet. Picture a 3-story building. Now picture the water arriving at the roofline and the time it takes to drink a cup of tea and read the news on your phone. And here is a detail that should stop you, because it is the single strongest argument in this entire story that Wednesday was not a freak one-off. This exact river corridor did this before. 13 months ago, On the 8th of July, 2025, a flash flood tore down the Lhende and the Lhende Khola and hit Rasuwa. That one was traced to the outburst of a supraglacial lake on the Tibetan side of the border. It swept away the Materi Bridge, the Friendship Bridge, the physical link between Nepal and China at that crossing. It killed at least 9 people, left dozens missing, including Nepali and Chinese workers, destroyed hundreds of parked trucks and electric vehicles waiting to clear customs, and knocked out hydropower capacity, feeding more than 200 megawatts into Nepal's national grid. Cross-border trade stopped. The Prime Minister visited. Reconstruction began. The road between Seismometers and Rasuwa was still being rebuilt from that flood when Wednesday's flood arrived and took it again. 2 catastrophic mountain floods, in the same narrow valley, in the same drainage, inside a single year, from 2 different mechanisms, one from a lake that burst, one from a glacier that fell. The people rebuilding after the first one were the people standing in the path of the second. I have covered a lot of repeat disasters on this channel. That sequence is the one that got to me. The physical damage tally, still preliminary, is severe. Nepal's Department of Roads reported roughly 41 bridges and some 42 kilometers of road destroyed or damaged, a figure that translates to about 26 miles of road, simply removed from a country where mountain roads are not a convenience but the only lifeline a village has. Initial government estimates put total damages near 200 billion Nepali rupees. Hydropower infrastructure along the corridor, some of it still being rebuilt after an earlier flood on this very same river system, was hit again. And now the part of this that matters more than any infrastructure figure. The human toll from this event is still being counted, and I want to be careful with these numbers because they are changing fast and because they are people. As of the most recent police updates, Nepal has confirmed 469 dead. More than 1,400 people remain missing. Another 466 are being treated for injuries. 28 Nepali police officers are themselves among the missing, and more than 4,000 have been deployed into the search. On the Chinese side, authorities have reported 3 confirmed dead in Gyirong County, with Chinese state broadcaster CCTV reporting 558 missing there, of whom 260 are foreign nationals. Behind every one of those figures is an ordinary Wednesday that did not finish. A local businessman in Nepal described taking a phone call from his brother-in-law that morning, hearing the family in tears down the line, and being told their entire house had been carried off. A teacher in the same area described watching trucks go down the river with people still in them. Those are the accounts reaching reporters from the accessible areas. The valleys that helicopters have not reached yet have not started telling their story. A large share of the missing were not local residents. The corridor that flood came down is a pilgrimage and trekking route. Many were traveling toward Kailash Mansarovar in Tibet, a journey people save for across a lifetime. Others were tourists, trekkers, truck drivers, and hydropower workers. Nepali tourism officials reported missing nationals from more than 24 countries. India has reported the largest number by a wide margin, with well over 100 citizens unaccounted for. Missing lists have also included citizens of the United States, Australia, the United Kingdom, Canada, Malaysia, Germany, South Korea, and others. South Korea established a government task force after several of its nationals working at a hydropower project were reported missing. That international spread is why this became a global story within hours, and it is also why the numbers have been so messy. Multiple governments are counting separately, some lists overlap across the border, and a person unreachable in a valley with no mobile signal and no road appears on a missing list whether they are trapped, evacuated, or simply out of contact. Which brings me to the most important thing in this video, and the part I will not skip. Missing is not the same as dead. I have watched a great deal of coverage over the past 2 days, some of it from very large accounts. Add the confirmed dead to the missing and present the sum as a death toll. That is not journalism, it is arithmetic performed on grief. Some of the missing will be found alive. In the 2021 Chamoli disaster in the Indian Himalaya, in the aftermath of other Nepali floods, people walked out of valleys days later. Others, tragically, will not. The honest position right now is that the confirmed figure is 469. The missing figure is over 1,400. Officials themselves expect the confirmed number to rise as rescuers reach cutoff areas, and anybody presenting a single tidy final total today is making it up. There is a second correction worth making, and it is the reason the title of this video says what it says. This was not a glacial lake outburst flood. You will see that term everywhere, usually abbreviated as a GLOF. It has a specific meaning. A glacial lake outburst flood happens when a lake that already exists, dammed behind ice or behind a ridge of glacial rubble, suddenly releases. Those lakes are cataloged. A study by the International Center for Integrated Mountain Development and the United Nations Development Program identified some 3,624 glacial lakes across Nepal, India, and Tibet, of which 47 were classified as potentially dangerous, including 21 inside Nepal. The lake that killed people on Wednesday was not on that list because on Tuesday it did not exist. Ekstrom noted that satellite images from before the collapse show no major lake forming in that area. Weather data recorded no excessive rainfall beforehand. The lake was created by the avalanche in a matter of minutes and destroyed itself shortly afterwards. Every early warning system, every hazard inventory, every monitoring program built around the idea of watching known dangerous lakes was, in this case, watching the wrong thing entirely, through no fault of the people running them. That distinction is not academic. It changes what preparedness even means. You can monitor a cataloged lake, you can install a sensor, run a siren line down the valley, and buy a village 20 minutes. You cannot monitor every unnamed glacier tongue in the Himalaya, and as buyers put it, you cannot predict these events. That is an uncomfortable sentence, and it is more honest than any reassurance I could offer you. It also helps to understand why this particular mountain range keeps doing this, because the Himalaya is a machine purpose-built for cascading failure. These mountains are young and still rising, shoved upward by the Indian plate, driving into Asia at roughly the speed your fingernails grow, which does not sound like much until you remember it has been happening for tens of millions of years. Young mountains are steep mountains. Steep mountains hold ice on slopes that would not hold ice anywhere gentler. Below that ice sits permafrost, frozen ground acting as a kind of structural cement, and beneath all of it run narrow, deep river valleys with villages in them because a narrow valley floor is the only flat ground for miles. Stack those facts, enormous mass held at extreme height on steep rock, bonded by frozen material that is now warming, above confined channels that funnel anything that falls straight into inhabited ground. There is no room for a flow to spread out and slow down. A valley that narrow does not dissipate energy. It concentrates it. That is why a collapse 12 miles from the nearest town killed people 50 miles downstream. So what about the question everybody is asking, which is whether this was climate change? Here is where the responsible answer and the viral answer separate. The viral answer is that global warming did this. Full stop, case closed. The responsible answer has 3 parts, and all 3 are true at once. Part 1. Scientists have not established a direct causal link between climate change and this specific collapse, and they say openly that doing so will take time. Attribution work is careful, slow, and specific, and it has not been done here yet. Anyone declaring the verdict 2 days in is ahead of the evidence. Part 2. The background conditions are not in dispute at all. Glaciers across the Hindu Kush Himalaya, the range that spans Afghanistan, Bangladesh, Bhutan, China, India, Myanmar, Nepal, and Pakistan, lost ice 65% faster between 2011 and 2020 than in the decade before. Nepal's glaciers have lost close to 1/3 of their ice volume in roughly 3 decades. As glaciers thin and retreat, they stop buttressing the slopes they sit against, and the permafrost that has been gluing rock and ice together for millennia begins to thaw. Ekstrom himself said that melting glaciers and permafrost probably contributed here. Satellite observations showed unusually warm conditions around that glacier before it failed, with snow cover reduced and more bare ice exposed to the sun. Part 3. The pattern of these disasters is not theoretical. In February of 2021, at Chamoli in the Indian Himalaya, roughly 27 million cubic meters of rock and glacier ice collapsed off the north face of Ronti Peak. The resulting debris flow carried boulders more than 20 meters across and scoured valley walls up to 220 meters above the valley floor. Over 200 people were killed or went missing, and 2 hydropower projects were wrecked. In 2016, an entire glacier tongue in the Aru range of Tibet sheared off in a way glaciologists at the time called scientifically new territory, something they had not believed was even possible. Byers, who has spent his career in these mountains, says plainly that these catastrophic floods are becoming more frequent. Hold those 3 parts together, because they are the truth of it. This one specific collapse has not been formally attributed. The environment producing these collapses is measurably and rapidly changing. The events themselves are stacking up. You do not need the 3rd fact to be proven by the 1st to find it alarming. Now, the part nobody wants to think about while rescuers are still working, and the reason this story is not over. There is another lake up there right now. The same cascade that produced Wednesday's flood left a new obstruction in the drainage near the border. China's Ministry of Water Resources activated a flood response and warned that a barrier lake formed near Gyirong Port is at high risk of breaching. State news agency Xinhua reported forecasts of roughly 3 million cubic meters of inflow into that lake over a period of 3 days, with rain continuing. 3 million cubic meters is 3 billion liters. It is the volume of more than 1,000 Olympic swimming pools, sitting behind a barrier made of exactly the same unengineered rubble that failed on Wednesday, above exactly the same valley, above rescue teams who are down there right now digging through mud. Chinese Premier Li Qiang traveled to Gyirong on Thursday to direct the response, and President Xi Jinping ordered an all-out search and rescue effort along with measures to prevent further disaster. On the Nepali side, more than 5,000 army and police personnel are working with helicopters, drones, and search dogs. India flew in about 10 tons of emergency supplies, including shelter, blankets, hygiene kits, and medicine. The International Federation of Red Cross and Red Crescent Societies released 1 million Swiss francs. The United States committed $500,000 and a disaster response advisor. The European Union activated its Copernicus emergency mapping service to feed satellite damage assessments to responders on the ground. All of that assistance is now working underneath a lake that officials themselves describe as high risk. One more thing, and then I will tell you what to watch. There is footage circulating right now, shared and reshared across every platform, that shows people being swept away by this flood in real time. I am not going to show it to you, and I would ask you to think twice before passing it on. Somebody's family is being tagged in those comment sections. The instinct to share is understandable. The people in that footage did not consent to becoming content. What is worth sharing instead is the thing that could save someone. In steep mountain terrain, if you see or hear a surge in a river valley, the correct move is immediate and vertical, not along the bank, not toward a vehicle, up the slope as high as you can get right away. Survivors of this event escaped precisely that way, by climbing the valley sides while others waited to see how bad it would get. In a flow moving at highway speed, the seconds spent assessing are the whole margin. If you have ever felt a river change behind you or been in a valley when the water came up, tell me where in the comments. In events like this one, the people who understand the warning signs fastest are almost always the ones who have seen something like it before. So here is what to watch over the coming days, and the reasons each one matters. Watch the barrier lake above Gyirong. Whether it drains slowly, is deliberately breached under controlled conditions, or fails on its own, will determine whether the rescue corridor stays open or has to be evacuated all over again. Watch the gap between the confirmed and the missing. That gap is currently the single largest uncertainty in this disaster. As helicopters reach cutoff settlements and as travelers make contact with their embassies, that number will move in both directions, and the shape of its movement over the next week will tell you what this event's true scale was. Watch for the satellite reconstruction. Planet Labs imagery, Copernicus mapping, and the seismic inversion of that long-period signal will, within weeks, produce an actual estimate of how much material came off that mountain and how fast it moved. Chamoli got that treatment, and the published analysis reshaped how these hazards are modeled. This one will too. And watch what happens to the monitoring question. Because the honest conclusion from Wednesday is not that a warning system failed. It is that for an unnamed, unstudied glacier tongue at 17,000 feet, there was no system to fail. Whether that changes, and whether the countries sharing this range decide to fund watching the ice above their valleys rather than only the lakes they already know about, is the part of this story that will still matter a year from now. A mountain came apart on Wednesday morning and wrote its confession into instruments on 2 continents, in a handwriting nobody recognized for hours. The people in the valley below never got to read it. Subscribe and turn on the bell, because Earth Signal is tracking that barrier lake and the missing count directly, and the next update on either one is going to matter.